Greetings grade 11s and grade 12s. We are going to be doing your 2D and your 3D shapes. But before we start, we will start with a bit of revision for what we've learned in the previous grades. So we'll start with the basics. When you have your right angled triangle, let's call this A, and let's call this B, and let's call this C. For now, we can call this theta, and this can also be called beta. That's what we learned. So as far as your theta is concerned, this will be your opposite side, because this is the side that is actually opposite to the angle, and this will be your adjacent side, and this will be your hypotenuse. And as far as beta is concerned, if we were to take beta into consideration, the opposite side is this one now. So this will be the opposite side to beta. This will be the adjacent side to beta, and the hypotenuse remains as the hypotenuse. We also have learned that we have your trig functions, which makes a myomic that we call. For us to be able to remember them, we have made a myomic, which is so ka toa. This can only work when you have a right angle triangle. Please remember that grade 11s and grade 12, this can only work when you have a right angle triangle, where this is sine, means that the sine of any angle, for example, let me just write this an angle, will be equals to, I don't want to say theta because you think it's always theta, the opposite, which is the O, over the hypotenuse, which is the H. The same applies for cos. So the cos of any angle will be equals to the adjacent side over the hypotenuse. Do the same thing for TOA. The tan of an angle will be equals to opposite over adjacent. This will help us to be able to remember those functions. I would also like to give you an example. Just move for space. Let me just go back. Let's come this side. As far as this triangle is concerned, I would say my sine of theta will be equals to the opposite. Remember, sine of an angle, like we said, the sine of angle is equals to the opposite over the hypotenuse. When you look at this triangle, the opposite side is equals to BC, and the hypotenuse is equals to AB. But for the same sine, but we're having a sine of beta this time, which is this angle. it will now be equal to the opposite side over the hypotenuse. Then the opposite side, the sine will be AC, and the hypotenuse will just be AB. Getting it? You can do the same thing for cos. The cos of theta will be cos to the adjacent side. That's what it's saying from SOHCAHTOA. Is equal to the adjacent side. As far as theta is concerned, the adjacent side is AC. AC over the hypotenuse, which is AB. And then for the cos of beta will be equal to the adjacent side is BC, as far as this is concerned, over the hypotenuse, which is AB. We do the same thing for tan. The tan of theta will be cos 2, because the base here is the same as, like we mentioned, the side. Is actually equals to the tan of any angle is the opposite over the adjacent, and as far as theta is concerned, the opposite is BC, and the adjacent side is AC. Do the same thing for beta. Will be cos 2. The opposite side is AC over the adjacent side is, the opposite side is AC. So this was AB. Let's fix this. The hypotenuse was AB. Please correct that. And then on the other side, we have AC as the opposite side, and the adjacent side is BC. Good. So we understand that the angle that you're talking about is very important for you to determine which side is actually opposite or adjacent. But the hypotenuse is always the hypotenuse, because the hypotenuse is always the side which is opposite to the 90 degrees. So the other thing that I also want to remind you is that when you have a triangle like the one that we have, a right angle triangle, if this is theta, this can also be written as 90 minus theta, because the sum of angles in the triangles needs to give us 180 degrees. So if this is already 90, it means these two angles will have to share the other 90. So if this is theta, from the 90 that is left, we take out theta and we'll be left with 90 minus theta. So in actual sense, what I'm saying from the previous diagram is we are saying your beta is actually equals to 90 minus theta, or your theta equals to 90 minus beta. We'll discuss this further when we get to the other topics. Now let's give ourselves an example, a practical example. if we were to have a triangle and in this triangle, let's call it A, B, C, and then D, and let this angle be equals to 40 degrees. And from what we know, you can see we have two triangles, is that given information will be AC being perpendicular to BD. Hence we have this 90s. And then our angle A is equals to 90 degrees. Oh, no, 40 degrees. As given on the diagram. And then let's say for example, they would like to have us to find the length of BD. If you look to the diagram, this is BD. Now, we'll also remember that because we have a 90 degrees, we'll think of our trig functions. So say, okay, the missing side is opposite to the angle that is given to me, because there's more information on this triangle. And I have a 90 degree this side. So I can use those trig function. Remember SOHCAHTOA. The angle is given. And let's say to make our problem much easier, let's say our AB is also given as 10 centimeters. And maybe our BC is also given as 18 centimeters. So we have 10 this side, and we have 18 this side. So we start with the one that has more information. So we have the opposite side, and we are also given the hypotenuse. So you will automatically think of your saw, because it has more information. You have the opposite side, that's what you're looking for, and you are also given the hypotenuse, and you have an angle there. So we'll simply say the sine of this 40 degrees, which is this, is equals to the opposite side, which is BD, the one that we're looking for, over the hypotenuse, which is 10. And then we need to make BD the subject of the formula. So as far as mathematics is concerned, we need to divide this 10, or we need to multiply by 10. Multiply both sides by 10. Whatever you do on the right, you must do on the left hand side. And then we can say BD will be equals to, because this 10 will divide this 10 sine of 40. And you press this in a calculator, it will give me a value of 6.43 centimeters. Remember, this is just our revision. And you can still do the same thing. Let's make things interesting. Let's say B, and then they ask you to find your angle C. Find the size of C. So your size of C, which is this angle, let's check it out. We are looking for this angle. Alright, apologies about that. It will then, what we can do, because you're looking for this angle, we can come to this triangle then. Focus on this triangle because you're looking for this angle. You now have BD, and now you are given 18. So we can still use sine because BD is opposite to this angle, and we still have the hypotenuse because it's opposite to the 90 degrees. So we'll have your sine of C is still equals to the opposite side, which is BD, all over your BC, which was given as 18. But you have the value of BD. So your sine of C is equals to the B what we found the side, 6,43 all over 18. This will give you a value. So for us to find that, we need to use our calculator and say C is equals to the second function of 6,43 all over 18. This can also be placed in the calculator the way it is, and the value of C will simply give us 20,93 degrees. I hope you get it. It's two examples where you have to find the side using the two functions, and when you have to find an angle. So this is our angle, just to freshen your mind and revise about before we go into your sine and cosine and area rules. And then let's say on the same problem, remember we got our BD as 6,43 and our angle C at 20,93 from the previous questions. If the examiner was to ask to say, can we find the area of this triangle ABC, which is the big triangle? Again, we remember the formula for the area is equals to 1 over 2. We learned this in grade 8 and 9. Base multiplied by the perpendicular height. Please remember that it needs to be perpendicular. Apologies. So if we were to take AC as our base, because already we have the perpendicular height, this will be our height. So we have BD, but we don't have AC. So what needs to happen? We need to go and find AC. before we can use this formula. So what we will do is, because we have two triangles, we cannot directly find AC. We'll use the two triangles with the information that we have. Let me use the first triangle. So each triangle A, B, D, I'm using this triangle. Because I have an angle and I'm looking for the adjacent side, then I will use cos for now. You can also use tan, but let's use cos. We will say the cos of this 40 degrees will be cos 2. Remember, cos is adjacent over hypotenuse. So our adjacent is AD over our hypotenuse, which was 10. Same. Multiply by 10, multiply by 10 on the other side. And then our AD will simply be the 10 cos of 40 degrees. When we press this in the calculator, it will give you AD being equals to 7,66 centimeters. Good. Do the same thing for the other triangle. A triangle BCD, which is this one. Remember, we found this angle as 20, so we'll use the cos again. We'll have cos, we'll just put a line, of 20.93 being equals to our adjacent side, which is DC, all over our hypotenuse from socket to water. So basically what we are doing, we are implementing car from the socket to water. And then our TC, using the same method that we used this side, will be equals to 18 the cos of 20.93. And our TC, if we press this in the calculator, it will give us 16.81 centimeters. Now that we have this side and that side, we can find AC. And then our AC will simply be 80 then plus DC. It's fine. And then when you add them together, AC and PT, you add this plus that, it will give us 24.47 centimeters. Now we have our base and we have our height. We substitute and say the area will simply be 1/2. What was the base? It's the one that we just found. It's 24.47 multiplied by the height, the BD that we found. Remember the BD that we found? So our BD will simply be, where's the value? 6,43. And our answer, if you put this in a calculator, will give us 78,67 centimeters squared. Good. So the whole problem was actually using the functions, the trig functions, because we had a right angle triangles. The other concept that I want us to touch on before we dive into the sine rule is your angles of elevation. Hope this is clear. Now let us explain the concept of angles of elevation. In actual sense, the angle of elevation is the angle between a horizontal and a line of sight up to an object. This is what I mean. Let's say we have a line, and then let me just do this so we can see. We have this angle, and then let's say our object is here. Like I said, the angle of elevation is the angle between the horizontal and the line of sight to an object. This becomes our angle of elevation. So if we were to look, so your eyes was actually here. Here's the object, the angle of elevation. This is you looking at this angle. So this will be the horizontal line, and this line will be parallel to this one from the object to the horizontal line. So this will be your horizontal line. And this will be our angle of elevation. And then we also have what we call the angle of depression. Let's write it here, angle. Please check the difference between the two. I'm going to draw again the horizontal line that I draw on top. Which is parallel. And then do this. Please do remember this is all going to be 90 degrees here. Good. And then this is the parallel line. And then my side is now this side. Look here, this is your eye. So our object will be the side. Where is our angle of depression? It will be here. So by definition, the angle of depression is the angle between the horizontal line and the line of sight down to an object. This is up to an object. This is down to an object. Right? Up to an object, down to an object. That means you're looking down. So this becomes your angle of depression. Makes sense? Good. All these concepts we are preparing so that when we talk about the sine and cosine rule and the area rule, you'll be able to actually follow. So we're just revising the concept that we actually have learned in the previous chapters and those that we have learned in the previous chapters. Please also note that your angle of elevation is always equal to the angle of depression. Why? Because if you look at it, if we have two parallel lines, this will actually give us alternating angles, because this will be our 90 degrees. This, we have two parallel lines, so this angle will be cos to that, and this will be cos to that. So because of the alternating angles, hence our angle of elevation is always equal to our angle of elevation. Please note that. Now that we have recapped, we are going to start with the area rule. Let's start with the area rule. I hope this is clear. Okay. So with the area rule, it's taking into consideration if we don't have a right angle triangle. So if we have the height here, like from the previous example that we just did, it's easier for you to be able to find the area because now you have a perpendicular height and you can find AC. But let's say you are given a triangle this is your triangle, and you don't have a perpendicular height, but you have an angle. You can use those angles. Let's say you are given this, so you can find the area of ABC. So the area can also be written as 1/2. Use the included angle. You must always use the included angle. So with the area rule, you must always use the included angle. I will also explain what is an included angle. An included angle is if you're going to use your sides. Let me say we're using A, B. Let me just call this a small letter C. Then there's a small letter B because it's opposite to B, and a small letter A because it's opposite to A. If you have B, it means you need to use side A and C because A and C are including B. They make an angle B. So we can say AC, and then we use the sine of B. The same is also true if we were to use C. Our area will be 1/2. Then we'll use AB and then the sine of C, because C is an included angle. And then if we were to use angle A, our area will be 1/2. Then we'll use BC, and its included angle will be A. So the area rule is as simple as ABC, because every time when you have A as a side and C as a side, B must be the angle. ABC, 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 ABC. So please make sure that when you are using the area rule, you always use the included side. So the area rule can be used. Let's recap. When you are given two sides, and an included angle, then you can use the area. So for us to use the first one, it means we need to have been given angle B and AC, A and C, side A and side C. Same applies to all of them. I hope that is clear. Now let us see the proof of the area rule. So I will start with the acute angles. I don't know what's wrong with this pen of mine. Let me just write it here. If we have an acute angle triangle, let's draw our ABC. Let's call it an ABC to make it easy for you to follow. It's an acute angle. It means none of these angles are above 90 degrees. I have A, B, C. So the opposite side will be A. This will be a small letter C, and this will be my B. Good. So what I will do, I'm going to construct a line, a perpendicular height, because I want to find the area. That's my perpendicular height. Let me call this D. So I have constructed, because I'm proving a theorem, and we have constructed your BD. And let's call this BD, let this BD of ours be h. It's our perpendicular height. Good. So we know the formula of the area. Is 1/2 the base multiplied by the perpendicular height, and we have our perpendicular height, but the height was not there, so we constructed it, so we cannot use it in the formula. So I'm going to use one of these triangles. I'll say, okay, in triangle A BT, which is this triangle, so also be 90. When I look at this angle A, I can say my sine, like we did before, let's try it again. The sine of A will be equals to the opposite over the hypotenuse. What is the opposite side? The opposite side is actually the h that we drew over the hypotenuse with our small letter c, which is this side. So we use this triangle. So we'll make h the subject of the formula. So our h will simply be c the sine of A. Good. So this will be our formula, the first formula, and this will be our second one. So we are going to substitute because h was not there. So the area now of ABC, let me just note it. This is going to give us the area of triangle ABC will now be equals to 1/2. What is the base? We'll use the base as AC. This will be the base. And we labeled it as SP. Multiply by the height. But our height was constructed, so we cannot use it. So let us substitute 2 into 1. So this will come in, and it will be C sine of A. So this will be 1/2 BC sine of A. So we have proved that if we use angle A, this will be the included side that we use. The sides. If we use this as an included angle, this will be the side I'm going to use. So similarly, this is also true, that the area will also be equals to 1/2 if we use this angle. It needs to use a different triangle. We use this triangle following the same method. You can also try it using the following steps. will give us, knowing very well that this will be A multiplied by B, then sine of C. So if this was to be used, if this angle was to be used, it means our construction will not be the same as this. We can actually use a different height. You can also try it. Good. That's the proof. Sorry. Let us now see the same area rule if maybe we were to be given an obtuse angled triangle. So I'll draw an obtuse triangle. I'll do it in two ways. Firstly, I will do the easiest one and the one that is not straightforward. This is ABC, and then this will be my C, this will be my A, and this will be my B. So normally what we will do when we want to find the area, we'll extend to find the perpendicular height. We'll extend this, and we extend that, and then let's call this D, and that will be our height. So if we can find that height, we can actually find the area. So the area will be our triangle ABC Alright, let me remove this. Will be equals to 1 over 2 the base multiplied by height. If I were to use B as my base, I need to know my height. So my base will be B, which is AC. If I had the height, this was enough. But I don't have the height, it's constructed. So we have constructed what we have constructed. We have constructed CD, was not there. And we also constructed BD. And we call BD our height. Now, if we can use the big triangle, you can say in triangle A, BD, which is this triangle here. I'm going to use this angle. We'll say your sine of A is equals to the opposite side, which is H, over C. And then my H will simply be C sine of A. And when I substitute this back, I'm going to have the area. Remember I said the perpendicular, the base was actually AC, which is B. Will simply be 1 over 2, the base being B, and then height being C sine of A. And we have done that. But I want us to look at another way. I'm gonna redraw the same triangle this side so you can see it. But I want to use angle C. Let me just make it a little bigger. Good. So this is A, B, C, and then this will be my B, this will be my C, and this will be my A. Still going to do the same construction this side. So this will be my 90 degrees. Let's call this D. Same construction. And then I'm going to have two angles now. I want to use angle C. So let me call this X. And then this angle this side will be, because of space, angles on a straight line, 180 minus X. Remember I said the area will be cos 2, 1 over 2 base multiplied by the perpendicular height. And my base will be B. So this is my base B. So I need to find the perpendicular height this side. So this will be my height. Good. So this will be equation number 1 of mine. Therefore, I'm going to use in triangle, let me call it CBD or BCD. I will have this angle, which is the sine. So the opposite side will be H. The angle is actually 180 minus X equals to the opposite. So I'm just using this triangle. And opposite is H. And then the hypotenuse of this will be A. And then we know that 180 minus X is in the second quadrant. And sine is positive in the second quadrant. So this will simply be sine of X equals to H over A. But from the original, before any construction, remember X was actually C. From the original. This is angle C. So I will have the sine of C equals to H over A. And and then my h will simply be a sine of angle C. I will then substitute this to equation number 1. Let me just erase this side. So we're done with this. So we can get some space. So when I substitute, the area, just right here, the area of triangle ABC will be equals to 1 over 2, then B, which was the base, and substitute A, sine of C. So the same will be equals to 1 over 2, rearrange it, AB sine of C. So we proved at least 2 of them. 2 different way of doing it. Whichever is easier for you, you can also follow it. But in most examination, the examiner will tell you prove that using the imperial angle as C. So you have to also remember the identities. Now that we are done with the area rule, we'll do problems later on. Let's go to the sine rule. Good. Let's see what the sine rule is saying. So if you have a triangle, remember we said these rules are used because we don't necessarily have your 90 degrees. So it's the tools that we are going to use when we cannot use the trig functions. So we create rules for them. So we have A, B, let's see. I don't know what's wrong with my B. Better. Looks like a B. Okay, our sine rule says let's define the size. Let us see, this is B and this will be A. Now when do you use the sine rule? You use the sine rule to determine an unknown length or maybe an angle on a triangle which is not right angled. So we can use the sine rule to find a side. You can also use the sine rule to find an angle. So for the sine rule to work, you either must be given so we need 2 sides and an angle. Let me just do this. It's two sides, so this can be clear, eh? All right, let me sort out this pen. So let me repeat it again. The sine rule will be used when you have two sides and an angle. But let's talk about that angle. That angle is not an included angle. So it's an angle that is not between the given sides, or else you must be given two angles and a side. So the other combination will you having two angles plus a side. Good. So these are the formulas for the area rule. Remember, we said we must be given two sides plus an angle, and this angle must not be an included angle. Are we okay? So we can say, if you are looking for a side, you put the sides on top. So you will say A over its opposite angle, the sine of its opposite angle, must be equals to B which is a side, its opposite angle will be here, and then the sine of B. I think I need to clear up my screen. So it's B over the sine of B. I hope you can see, guys. And C, the sine of C. There's a small letter C. I'll just make it small letter so you can see it. But because this is a ratio, one can also write this and say, if I'm looking for an angle, I'll put the angles on top so that making the sum of the formula becomes easy. Sine of A over A, the sine of B over B also will be equals to the sine of C over C. So we'll then jump into the proof. If you have any questions, please, you can comment below so that we can assist.